Okay, so I am working through your example problems over pH. And so our first one says, what is the pH? Okay, we need to know the pH if we have a 0.325 molar solution of potassium hydroxide. Now, hopefully you know that KOH is a base, and so this is the concentration of a base. So in order to find pH, you've got several ways you could go about it, but what you could do is, or what you probably need to do is find your pOH, okay, first. And then remember that your pOH concentration, you've got two things, either your concentration of your pH and your pOH equals the kW, the 1 times 10 to the negative 14, or you could use the pH plus the pOH equals 14, which is probably what I would suggest you do. Now, you could definitely go through and do your concentration. I like to do my pH and my pOH. So I'm going to do negative log of my OH concentration and, and so put that number in real quick to your calculator. Okay, so I put it in and I get a pH or pOH of 0.488. And again, if I'm looking at significant digits, I have 3 there, and there's my 3 afterwards. And then I actually want the pH, so I am going to have that my pH plus my pOH is 14. Therefore, 14 minus my pOH will give me, so I get 13.512 as my final answer. Okay, now I do want to show you if you had done the other formula here. So if I had put in my kW as 1 times 10 to the negative 14, if I had put my OH concentration in here, that would have divided it off. There's what I did. There is my hydrogen concentration, and then I would have had to put it into the negative log answer, and again you can see that I get exactly the same number. So that's 2 different ways, so you can kind of take your pick on some of these, which order you want to do things in. Okay, let's look at the next problem then. It says a solution was made using NOH, again a base. The pH of the solution was found to be 11.452. What is the concentration of the hydronium ion? So this is just the complete reversed problem. So again, they give us that the pH is 11.452 on that. So that means my pOH is going to be 14 minus 11.452, which is going to be 2.548, and that again is my pOH, which is how I found this here. And so we know that pOH is the negative log of my concentration, and we just found that value. Now you can probably skip some steps, but I'm just showing you where I'm getting this. And then again, if you think of that as a base 10, this is 10, and I would divide the negative off first. So negative 2.548 is going to be my concentration. So I'm just going to put that into my calculator, and I get 0.00283. Now, technically I've got quite a few digits there, so I could go on out. That would be 14, okay, as my hydronium ion concentration. So that would be my final answer. Okay, okay, I'm going to skip number 3 as an example. I want to do that with you in class. So let's go on to number 4. And you're welcome to try number 3, but that goes back to last chapter, setting up a reaction and looking to see if you form a precipitate. Okay, here we go. It says at 50 degrees, so I've changed the temperature. Here's my new kW value. We're going to calculate the hydronium ion concentration and the hydroxide ion, and then also find pH and pOH. So again, remember that, and it's pure water, that's a key. So remember that we have that our kW is the two concentrations multiplied together. And so in this case, it is 5.476 times 10 to the negative 14. And as I said, the pure water piece is very important because remember I told you earlier that in pure water, the pH and the, concentrations are going to be equal, also the pH and the pOHs also, but so I can put an X in both of those positions. And so I'm just going to end up taking a square root of that number. Okay, and I get 2.340 times 10 to the negative 7. Again, be sure you check that. Therefore, if this is my concentration of both my hydroxide, so we could write this out to actually answer the question, those are going to be the same value. Okay, and then again, I can do my pH as being the negative log of my concentration and see what I get. Okay, so once I put in again the negative log, I come up with 6.631. Now let's talk about significant digits while we're here on there. Actually, I need one more. Let's see, 07, sorry, 08. Just notice that. So you have, again, 4 significant digits here, 1, 2, 3, 4 in that, so that would be 1, 2, 3, 4 out here. Okay, and then if you, again, pure water, your pH and your pOH are going to be the same value, so 6.6308. Okay, and those would be all of our answers that we needed. Okay, so let's try another one. And again, at any point, you're welcome to try it without me and then just check to see if you agree with my answer. This one is, what is the pH when the concentration is this? Now, you know, they're giving it to you this way, so you've got to know if that is an acid or a base, and hopefully you know that that is one of our strong acids. Again, had it been a base, you'd have had to do something different, but our rule is simply just the negative log of our concentration. And we're just going to run that number in our calculator. And again, watch. Okay, and I get a pH of 1.3. So be sure you check my numbers, guys. Remember, sometimes I get things wrong. So this one says to find the pH. It gives me NaOH, and here's my concentration. So again, this is the one that's going to try to be tricky for you because they give you a base. So this is the concentration of a base, so I can find pOH, negative log of my concentration. Okay, and then I'm going to need to use my rule that pH plus pOH is 14. So let's run that and see what we get. Okay, so let's see. First off, how many of you caught what I did, because I did once I went to this problem, and I didn't do significant digits over on this one, so I went back and changed it. I have 3 significant digits, so there's my 3 digits. I had to go back and fix it. You guys catch me. And so here it's 1.301, because again it's the same as what I just did up here, but this time it is the pOH, not the pH, and so I needed to do my subtraction, and therefore my pH is 12.699. Okay, so our next one's what is the molarity of the hydronium? And again, we need to decide if it is an acid or a base. So if it is 3.689, then again, that should be an acid. And we're going to go ahead and put that in because, again, pH equals the negative log of the hydronium, which is what I'm looking for. So if you'll remember, when I have the pH given, then we do 10 to the negative pH. And that will give me my concentration. Okay, and so that is, again, my answer. Okay, next one is basically the same thing. That I should have probably given you one with pH and one with pOH, but that one's going to work exactly the same way, so I think I'm just going to skip through that. And then here is a pOH, again, where it gives us the concentration already. So again, remember, pOH is a negative log of the concentration, and I know the concentration on this one. So I can just put that in my calculator. Okay, and again, I just ran that in my calculator, and I get a pOH of 3.807. Now I'm not done because it asked me for the molarity of my hydroxide ion. So I am now going to calculate my pH, 14 minus 3.087. Okay, and so there's what I got when I ran it in my calculator. So again, do the 10 to the negative pH and get our answer. Okay, so I skipped over on the previous page one, and I'm going to go ahead and skip this one also, and we're going to come back and do those two, because again, those are starting to look at dissociation. So again, the same, when you go to your assignment over on the next, I'm not sure that there is any, but if there is a couple that, yeah, it does look like maybe number 11 on there is one that has to do with dissociation also. So again, you might need to, until we talk more in detail, skip a couple. Okay, good luck on doing those.